How's it going, everyone? So today we are going to go over a very popular algorithm problem called Decode string. This question is asked at Google, Microsoft, Bloomberg, Uber, Amazon, Snapchat, Facebook, and a whole bunch of other companies. This problem is very difficult, especially if you are uncomfortable using the stack data structure. But no worries, I'm going to go through it and explain it step by step. All right, so for this problem, we are given an encoded string that could look something like this. And we have to decode this string. And by the end of decoding it, we should be left with only letters and no digits or brackets. So let's call the digits in the string as k. Each number k will always sit in front of a square bracket, and the letters inside of the square brackets have to be repeated k times. So let's look at the first part, 3 bracket a. This is saying we must repeat the letter a 3 times, which evaluates to AAA. The next part we repeat the letter b 2 times. Finally, we are left with the letter c, which has no k digit in front of it, so our final result after decoding this string would be AAA, BB, C. So far so good, but what if we have a nested encoded string that looks something like this? This is obviously a lot more complicated. For this example, we can't just evaluate left to right. We actually have to decode the string starting inwards and going outwards. This is where the use of the stack data structure will come into play. Now, I'm sure you might be wondering, how do you know to use a stack? What is the intuition to know to use it? A stack uses the LIFO approach to process data, last in, first out. An easy way to recognize if a stack needs to be used is if the last data, and in our case, last is the most nested characters, must be consumed first. The nested characters must be evaluated first, and this aligns directly with what a stack offers. Hopefully this makes sense for you. It is crucial in identifying when a stack is actually needed. So let's move on to the algorithm using our stack data structure on this nested encoded string. So we have a total of 4 different types of characters that can be present in our encoded strings. We have digits, letters, an open bracket, and a closing bracket. We'll need to keep track of the digits and letters as we iterate over the string. So we will have one stack for the digits and another stack for the letters. And we can just call it count stack and word stack. We will also need a variable called number for keeping track of the number that we are iterating over. So a digit can be more than one character long, obviously. So for example, we could have a digit, say 25. It is not necessarily going to be a single digit, so this variable will hold the digit data. Lastly, similar to the number variable, we will have a variable called word to keep track of the letters we iterate over. Now we can iterate over our encoded string. So starting on the left side, we have our index at the character 2, and this is obviously a digit, so we're going to add 2 to our number variable. Next, the character we're at is an open bracket, and anytime we encounter an open bracket, this means we are at the start of an encoded string. At this point, we will have a number and a word that we can now add to the stack. So starting off with our count stack, we would add the number variable to our stack. And right now we just have the number 2. And then our word variable is currently an empty string, so we're just going to add an empty string to our word stack. After we've added those variables into our stacks, we can just reset our variables. So the key takeaway for an open bracket is that we are starting the encoded string. By this point, we will have a digit that we have built and a word that we have built. That's why we added them to the stack. Next, we're at the A character, and since it is a letter, we're just going to add it to our word variable. Then we move to the character 2. That's obviously a number, so we add it to our number variable. And then we arrive at another open bracket. So same as before, we're going to add the word and the number to their respective stacks. And then once we add both of those variables, we will reset them. Next, we're at character B. We add it to the word variable. Then we're at character C, add it to the word variable. Then we go to the character 2, we add it to the number variable. And then once again, we hit another open bracket, which means we are at the start of another encoded string. So we're going to add the word and number variables to their respective stacks. And then we will also reset the variables after we do that. Next, we arrive at a character D and we add it to our word variable. And now we're finally going to get to a closing bracket. So this character means that we have all of the information we need to decode one of the nested strings. So just to reiterate, an open bracket means the start of an encoded string, and then a closing bracket means the end of an encoded string. Pretty simple. So first, we're going to need to pop from our word stack, which is the string BC. And then we're also going to pop from our count stack, which would be 2. And notice that we have our word variable set to D. This is the encoded string for this specific section. And since we popped a 2 from our stack, we need to repeat the character D 2 times since we just pulled that digit from our stack. And once we do that, we would get the string DD. The next step is the BC string is the beginning portion of this encoded string, because as you can see in the string BC, it comes before the section 2 bracket D. So we're left with, as our decoded string, BCDD. And then the final step is the decoded string will be assigned to the word variable, because this decoded string may be nested in other encoded strings. So our word variable becomes BCDD, which is the string that we just decoded. So as you can see, the nested encoded string has been decoded, but we are still inside of other encoded strings. So we have to continue. So when we move to the next character, we hit another closing bracket. So we're going to do all the same steps as we did before. We're going to pop from the word stack, we get the character A. We're going to pop from the count stack, we get the number 2. And then we repeat our word variable 2 times. So that would be BCDD, BCDD. And then we're going to add A to the beginning. And then we assign this decoded string to our word variable. So our word variable is now ABCDD, BCDD. Next, we're going to move to another closing bracket, and we're going to pop from our word stack, which is an empty string. We're going to pop from our count stack, which is the number 2. And then we repeat our word variable 2 times. Then we're going to make the empty string the beginning, which obviously doesn't do anything. And then finally, we're going to assign this decoded string to our word variable. And now we are finished with the iteration, and the word variable will contain the entire decoded string. All right, so let's implement the code for this solution. We are given a string S, which is obviously an encoded string, and then we need to return a string, which will be the decoded string. So starting off, we're going to create both of the stacks, one for the numbers and one for the letters. So one stack is going to hold integers and another stack is going to hold the strings. Next, we're going to initialize the number variable like we discussed. And then we're also going to create a string builder, and we can call this word and initialize that. All right, now that we've done that, we can just iterate over our encoded string. And in here, let's extract the character. Just call it character C, and we'll say s.char at I. And remember, we have 4 different types of characters. We can have letters, digits, an open bracket, or closing bracket. So first, we can say if the character is a digit, Then we're going to do some logic in here. Else if the character is a letter, do some logic in here. Else if C is equal to an open bracket, do some logic in there. And then finally, in this else statement, that would be the closing bracket. All right, so let's first implement the logic for when we encounter a character that is a digit. So remember, our digits could be more than 1 in length. We could have a digit that's, say, 200, right? So we need to make sure that we build this number as we iterate over our encoded string. So I'm going to write this out first, and then I'll explain what it's doing. So we're going to say number equals number times 10 plus the character minus the character 0. Some of you might know what this is already doing, but I'm going to explain it anyway. So starting off with the C minus character 0 portion, why are we doing this? So character 0 in decimal is the number 48. And we already verified that character C at this point is a digit. It could be anywhere from 0 to 9 as a character. And when we subtract characters from each other, we get integer values. So for example, let's say C is character 1. If we did character 1 minus character 0, that would evaluate to the number 1. So essentially what this C minus character 0 portion is doing is it's just allowing us to do conversions of character C to an integer value. That's all this step is doing. And then the other section, number times 10, why are we doing this? So as an example, let's say we were building the number 15. We would get a 1 and then we would get a 5. We need to, build that number. So when we're building it as integers, we need to make sure that we account for the place that we're at. So as an example, let's say we see character 1 first. That would mean when we do C minus character 0, that would equal 1. Number is at 0. So if we did 0 times 10, that's 0 plus 1. So we have 1 so far. And then if we encounter, say, a character 5 next, what that would mean is we do number times 10. That would be 10 plus C minus character 0, which would be 5. So we do 10 plus 5 equals 15. So as you can see, we're actually building the number as we iterate over our string. So hopefully that made sense. I tried to explain it as best as I could. So the next piece of logic we need to implement is when our character is a letter. And this is really simple. All we need to do is say word.append C. Next, when we encounter an open bracket, we need to add both the number and word to our stacks. So we're going to say count stack dot add, and we're going to add the number, and then we're going to do word stack dot add word dot toString, and then we need to reset our variables. So we'll say number equals 0 and word equals new string builder. And then finally, we need to implement the logic from when we hit a closing bracket. So first, we're going to pop from our count stack. So we're going to say int count equals count stack dot pop. And then we're going to pop from our word stack as well. So we're going to say string builder. And we can call this duplicated word because we're going to duplicate it however many times count is, equals new string builder word stack dot pop. And now we just need to duplicate this word however many times count is. So we'll say for int I equals 1, I is less than or equal to count. And we're going to say duplicated word dot append word. So we've duplicated the word count times, and then the final step is just assigning word equal to our duplicated word. So word equals duplicated word. And then finally, when we come out of the for loop, we're just going to return word dot to string, because by the end of iteration, the word string builder will be the entire decoded string. All right, so let's submit this to see if everything worked. And of course, I messed something up. I used the I variable. This needs to be changed to a J variable. All right, let's submit one more time. And there we go. It all works. So our time complexity is going to be m times n, where m is the number of times we have to repeat an encoded string, and n is the length of the entire string. We iterate over each character, which is the big O of n portion. Then we encounter a digit that we have to repeat, a substring, which is the O of m portion. So that's why they're multiplied together. And then our space complexity is going to be big O of m plus n. We initialize 2 stacks, one for the number of digits we have, and one for the number of letters. And the number of digits and letters can be different. So that's why we have to define different lengths for these variables, m and n. One of the hardest parts of stack problems is just identifying when to actually use a stack. So I hope this video answered this question. If you need more stack practice, I have a couple other videos that I go over in depth, just like this one. And that is all I have for you all, so I will see you next time.